Hello grade 10, welcome to my channel. This is Tutor Marife, and in this video I will tutor once again finding finite sum of a geometric sequence, but this time the set of given values are different from our past problems. Okay, we have the first term, the last term of the geometric sequence, and the common ratio. Dun sa mga naunang na-solve natin, wala tayong final term as given. Instead, we have the number of terms to be added. Okay, so dito naman, wala tayong bilang ng terms to be added. Okay, so it's one of our hidden problem, yung n, para ma-solve natin yung finite sum of this geometric sequence. Okay, so again, ang focus natin ay yung sum formula, the finite sum formula of a geometric sequence. It's S sub n equals A sub 1 times the quantity 1 minus r raised to n all over 1 minus r. You use this formula when your common ratio is less than 1. So let's check. Our common ratio is negative 2. And negative 2 is indeed less than 1. So tama ang napili nating formula. Kasi we have other option. Yun yung nakaswap yung binomial sa numerator at binomial sa denominator. Nakaswap yung terms ng binomial sa numerator at yung terms ng binomial sa denominator. So, yung other option mo naman is when r is greater than 1. Okay? So, ito yung main formula natin. To be able to find the sum of the sequence, the geometric sequence, we need 3 information. We need a sub 1 and it's given. So, walang problema sa a sub 1. We need r. It's also given. No problem ang r. But we don't have n. So, this is our hidden problem. Before we can solve the sum, we need to know what's n. How many terms are we going to add? Okay? So since the final term of the geometric sequence is known, we can use this to solve n. Let's review the explicit formula for any term of a geometric sequence. It's a sub n equals a sub 1 times r raised to n minus 1. And this is also called the general term of a geometric sequence. Okay? So, using this equation, we know a sub n, it's given. We know a sub 1, it's also given. We know r, it's given. So, the remaining variable will be n. Therefore, we can solve for n using this equation. So, it's our step 1, solve for n. After that, we can proceed to finding the sum of the geometric sequence. Step 1, we find n. Okay, so let's use the explicit formula. For any term of a geometric sequence. And that's a sub n equals a sub 1 multiplied by r raised to n minus 1. Okay, let's plug in the given values. A sub n, that's 1024. A sub 1, that's 4. Multiplied by r, negative 2. raised to exponent n minus 1. Okay, so nag-substitute lang tayo ng mga given values. Next step, we're trying to solve for n. So pag we're solving for n, tapos this term, the exponential term, involves the unknown, we don't need 4 on the right side. So we need to eliminate it from the right. So since it's being multiplied to this exponential term, we eliminate 4 by the inverse operation of multiplication, and that is division. So the only way to cancel out times 4 on the right side of the equation is to divide 4. Yeah. This is our target, to cancel out the 4. And by division property of equality, we also have to divide left side by 4 para balance. Okay, so let's simplify the left side. We're dividing by 4, so it's 1024 divisible by 4. What's the divisibility rule for 4? If the number formed by the last 2 digits of the number is a multiple of 4, then 1024 is divisible by 4. What's the number formed by the last 2 digits? 24. Is 24 a multiple of 4? Yes. Therefore, 1024 is divisible by 4. Okay? So, bawal ang calculator, kaya we apply the divisibility rule. 1024, divide natin by 4. 10 divided by 4 is 2. Remainder 2. Yung remainder 2, imagine na nasa kaliwa ng next digit na 2, magiging 22 divided by 4, 5. Remainder 2. Yung remainder ulit na 2, imagine na nasa tabi ng 4, 24 divided by 4, 256. So actually, 256 times 4 equals 1024. So this is the quotient on the left side. Your right side becomes the exponential expression. Negative 2 raised to the exponent n minus 1. Okay? So, paano yan? Paano mo isosolve ang n kung nandun siya sa itaas? Pag ganito, itry mo na i-rewrite yung left side mo into exponential form with base that's the same as the base of the right side. So, ano ba ang base ng right side mo? It's negative 2. Question, can we rewrite 256 into exponential form having a base of negative 2? If we multiply negative 2 or we use negative 2 as a factor multiple times, ilang beses yon to arrive at a product of 256? So, ano yung magiging exponent niya dito? Negative 2 raised to, your exponent must be an even number. Kasi, if you raise negative to an even power, the result would be positive. Kasi 256 ang gusto mong i-rewrite. It's actually 8. You double check. Negative 2, use it as a factor 8 times, the result will be 256. Equals your right side negative 2 raised to n minus 1. So, bakit natin ginawa yan? Kasi, kapag naipakita mo na you have two exponential terms on both sides of the equation and they have the same base number, then, pwede mong i-equate yung mga exponents. Pag pwede mong i-equate ang mga exponents, yon, bababa na yung unknown mo. Mula sa bandang itaas, bababa na siya. So, parang kina-cancel out mo yung common base. Okay, remember that you cannot equate exponents on the left and on the right if the base numbers are not the same. They should be the same para magawa mo yung equating of exponents. Okay, so we equate the exponents. Exponent on the left is 8. Exponent on the right is n minus 1. Naging simple linear equation in one variable. We solve for n, transpose negative 1 to the left para ma-isolate na yung n, 8 plus 1. So, n is equal to 9. If n is equal to 9, that means we are adding up 9 terms of this geometric sequence. And your a sub n, this 1024 is actually the 9th term of the geometric sequence. Okay? So, na-solve na natin yung hidden problem. Dun na tayo sa main problem. It's the finite sum. Step 2, solve for the sum of the 9 terms of the geometric sequence, S sub 9. So, it's equal to a sub 1, 4, times the quantity 1 minus, you plug in your r, it's negative 2. Raised to, your power is 9. Close. All over 1 minus, again your r is negative 2. Okay? So, it's 4. Dito sa loob ng brackets, we finalize the connector between the first number, and that's 1, and the exponential number 2 raised to 9. Ano yung final connector between the two? Let's count the negative signs. Since negative is included inside the parenthesis, it also owns the exponent 9. So, ang bilang ng negative natin dito sa exponential expression na negative 2 enclosed with parenthesis raised to 9 is 9. Meron kang 9 negative. Idagdag mo ito, itong nakatabi, plus 1 negative. Altogether, you have 10 negative signs. 10 is an even number. If the number of your negative is even, your final sign or your result will always be positive. Yan. So, itong 1 minus negative 2 raised to 9 becomes 1 plus 2 raised to 9. All over 1, count the negatives, 1, 2. You have 2 negatives. 2 is also even. This is also even. Therefore, the result will be positive. So you have your first number 1, your second number is 2. Our final connector or operation between the two will be positive. Okay? Again, this is a grouping symbol called vinculum. And by the Gemdas rule, perform operations within vinculum before you proceed to other operations. G first. So there is an addition and exponentiation on the top of the vinculum, and there is addition at the bottom of the vinculum. I-perform muna natin ang mga yon. So, 4 times. What is 2 raised to 9? Exponential before addition. So, it's 1 plus, what's 2 raised to 9? We know that 2 raised to 8 is 256. Isa pang times 2, 256 times 2 is 512. All over, you add 3. Hindi pa rin nawala ang operation sa G. This time, we have the brackets as your G. You add 4 times 513 all over 3. Okay? You can reduce before you multiply. Kasi pwede mo ring i-rewrite ito na 4 multiplied by 513 over 3. The same lang yan. So, pwede kang mag-reduce before you multiply by 4. So, 513, is this reducible by 3? You add the digits. 5 plus 1, 6 plus 3, 9. If the sum of the digits of a number is a multiple of 3, then the number is divisible by 3. So, pwede itong i-divide by 3. And what's 513 divided by 3? 51 divided by 3 is 17. 3 divided by 3 is 1. So, it's 4 times 171, and it's equal to 4 times 171 equals 684. Evaluate the geometric series. This is the final answer. If you have questions, use the comment box. Again, please subscribe to my YouTube channel. It's Tutor Marife MCP. Thank you.